Dear students, welcome to my classroom. In previous classes of statistics chapter, we learned how to find the mean of given data in various methods that are direct method, assumed mean method, and step deviation method. And in this class, we are going to learn how to find the mode of group data. How to find the mode of group data. Before going to learn that, let us rewind the points what we have learned in previous standards about mode and how to find the mode of ungrouped data. Okay, so our our concept is mode. So mode is one of the three measures of central tendency apart from mean and median. So, but how to find the mode of ungrouped data? So in statistics, the mode is the most commonly observed value in a set of data. That is, we can also say that the value or number in a data set which has a high frequency or appears more frequently is called mode or model value. That is, the number or value which appears more frequently is called mode of the given data. For example, in the given set of data 2, 4, 5, 5, 6, 7, the mode of the data set is 5 since it has appeared in the set twice. Okay, so here 5 comes twice. So the mode of this data is 5. So a set of values may have one mode or more than one mode or no mode at all. For example, the mode of observations 2, 2, 2, 3, 4, 4, 5, 5, 5 is both 2 and 5 because both 2 and 5 is repeated 3 times in the given data. Okay, so here 2 came 3 times and 5 came 3 times. So both 2 and 5 came 3 times, so that the modes of this given data are 2 and 5. So the data is called bimodal as it contains two modes. As the data contains two modes, it is called bimodal. And the data with one mode is called unimodal. Okay, the data with one mode is called unimodal, and the data with two modes is called bimodal. And similarly, the data contains three modes is called trimodal. And in this way, when there are four or more modes, then the data is called multimodal. Okay, unimodal for one mode, bimodal for two modes, trimodal for three modes, and multimodal for four or more modes. Okay, so let us learn that how to find mode of group data. Okay, so in a grouped frequency distribution, it is not possible to determine the mode by looking the frequencies like ungrouped data. Here we can only locate a class with the maximum frequency, which is called the model class. Okay, we can locate a class with the maximum frequency is called the model class. The mode is a value inside the model class and is given by the formula L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. So where L is lower boundary of the model class. And what is model class? The class with the maximum frequency. The class with the maximum frequency is called the model class, and we denote the lower boundary of the model class by L, and F1 is the frequency of the model class, which is the maximum frequency, and F0 is frequency of the class preceding the model class. F0 is the frequency of the class preceding the model class, and F2 is the frequency of the class succeeding the model class. And H is already we know that size of the model class interval. H is the length of model class interval. Okay, so by substituting these values in this formula, we can find mode easily. Okay, so we have to remember that the formula to find the mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Let us see an example for finding the mode. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. So this is the table which shows the results of survey. In first row we have family size, and in second row we have number of families. So 1 to 3 is 7. That means the number of families having family members from 1 to below 3 is 7, and the number of families having family members from 3 to below 5 is 8, and similarly from 5 to below 7 is 2, and from 7 to below 9 is 2, and from 9 to below 11 is 1. So here we can notice that the maximum frequency is 8. Okay, here the maximum class frequency is 8, and the class corresponding to this frequency is 3 to 5. Okay, so maximum class frequency is 8, and the class corresponding to this maximum frequency is 3 to 5. So here the 3 to 5 is model class. Okay, now lower boundary of the model class is L is equal to 3. Now frequency of the model class is F1 is equal to 8, and frequency of class preceding the model class is F0 is equal to 7, and frequency of class succeeding the model class is F2 is equal to 2, and size of the model class interval is H is equal to 5 minus 3 or 3 minus 1 is equal to 2. Now the mode is equal to L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. Now by substituting values, we get 3 plus 8 minus 7 by 2 into 8 minus 7 minus 2 into 2, which is equal to 3 plus 1 by 7 into 2, that is 3 plus 2 by 7. So by dividing 2 by 7, we get 0.286, so that the value is equal to 3.286. Therefore, the mode of the given data is 3.286. That is, this is the solution of a given example. So in this example, the mode we got that 3.286. That is, most number of families had a number of family members 3.286. Okay, so let us solve the problems in exercise 14.2. which are related to find the mode. Okay. Exercise 14.2. So the first problem is, the following table shows the ages of the patients admitted in a hospital on a particular day. In first row, age is given in years, and in second row, number of patients is given. That is the number of patients that are admitted from age to below age from 5 to below 15 years is 6, and the number of patients admitted between the age from 15 to below 25 is 11, and similarly from 25 to below 35 is 21, from 35 to below 45 is 23, from 45 to below 55 is 14, from 55 to below 65 is 5. Find the mode and the mean of the data given above. Compare and interpret the two measures of central tendency. Here we have to find both the mode and the mean, and also we have to give an interpretation about the result we got. Okay, so to find mode, we have to take the same table in vertically. Okay, 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55, 55 to 65. And the frequencies are 6, 11, 21, 23, 14, and 5. So in this table, the maximum frequency is 23. So the model class is 35 to 45. So the class contains the maximum frequency is 35 to 45. So we take the model class as 35 to 45. And now the lower boundary of this model class is L is equal to 35, and the class frequency of the model class is F1 is equal to 23, and the frequency of the class preceding the model class is 21. We denote it by F0, and frequency of class succeeding the model class is F2 is equal to 14, and size of the model class interval is 15 minus 5, or we can take 45 to minus 35 is equal to 10. Okay, now we have mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Now by substituting all these values in this formula, we get 35 plus F1 is 23 minus F0 is 21 by 2 into 23 minus 21 into F2 is equal to 14, and H is equal to 10. Now by simplifying this one, we get 35 into 2 by 11 into 10. So and 2 into 10, 20 by 11 is equal to 1.82. That is 36.82. Okay. Now the mode of given data is 36.82 years. That is the most number of patients admitted in the hospital are of age 36.82 years. So in the question, it is also given that to find the mean of the given data. So let us find the mean of given data. So to find mean, we have to take two more columns. First one is class marks. So that is the mid values of given classes. So mid value of 5 to 15 is 10, and mid value of 15 to 25 is 20. 25 plus 15, 40 by 2 is, that is 20, and 35 plus 25, 60 by 2 is 30, and similarly 40, 50, and 60. Now the fourth column we have to take is Fi into Xi. That is the products of Fi's and Xi's. 6 into 10 is 60, 11 into 20 is 220. 21 into 30 is 630. 23 into 40 is 860. Sorry, 920. 14 into 50 is 700. 5 into 60 is 300. Now, sum of these frequencies is given by sigma fi is equal to 80. And sum of the values fi xi is denoted by sigma fi xi is equal to 2830. Now, the mean of given data is equal to sigma fi xi by sigma fi. So, 2830 by 80, which is equal to 35.375. So, the mean of given data is 35.375. That is mean age of patients here. What is the mean here? Mean age of patients is 35.37 years. So, what can we interpret about these results? So, the mode age is 36.8 years and mean age we got is 35.37 years. That means maximum number of patients admitted in the hospital are of the age 36.8 years, while an average age of patients is 35.37 years. Okay, students. So that can we interpret here. So let us take second question. The following data gives the information on the observed lifetimes in hours of 225 electrical components. So here lifetime in hours is given in first column, first row, and frequency is given in second row. That is the number of components having lifetime between 0 to 20 hours is 10, and the number of electric components that having a lifetime from 20 hours to below 40 hours is 35, and so on. 40 to 60 is 52, 60 to 80 is 61, 80 to 100 is 38, and 100 to 120 is 29. So determine the model lifetimes of the components. That's the question. We have to find model lifetime. That's the mode of lifetimes. Okay. So to find mode of given data, so take the given data vertically, lifetime in hours and frequencies, which are given in question. So in this table, we can notice that 61 is the maximum frequency. Okay, so we can take the model class as 60 to 80. So model class is 60 to 80. And now the frequency of this model class is F1 is equal to 61 and lower bound of the model class is L equal to 60. Frequency of the model class is F1 is equal to 61 and frequency of the class preceding to model class is F0 is equal to 52. And similarly, frequency of the class succeeding the model class is F2 is equal to 38. That is a frequency of the class before the model class is F0 and frequency of the class after the model class is F2. And here the length of class interval is H is equal to 80 minus 60, which is equal to 20. Now the mode of the given data is equal to, already we have seen that L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. And now by substituting these values, 60 plus F1 is 61, F0 is 52, F2 is 38, and H is equal to 20. We get 60 into 9 by 61 minus 50 is 9 by 122 minus 90 into 20, and that is equal to 180 by 32. 60 plus 180 by 32, and which gives us 5.625 and is equal to 65.625. So the model lifetime of the given electrical components is 65.625 hours. That is, most of the electrical components have the lifetime 65.625 hours. Okay, students. So that's all for today. In next class, we shall solve some more problems regarding to mode. Okay. Until then, see you. Bye.